This video is going to be in two parts. Part 1 is going to demonstrate the Key 4017 chaser encoder, and part 2 will demonstrate the Key 2-wire encoder. Both of these encoder boards connect to the Keypad 40 keypad. Alright, so I'm going to go into the first part first. Alright, that's going to be the part 1, which is the Key 4017 chaser encoder. These are the manufactured boards I'm going to be demonstrating. Okay, so I'm going to bring a schematic. I'm going to bring a picture of it up right here. Okay, all right, this is a picture of the board itself. This is the CD 4017 decade counter. This is the PCF 8574 expander IC. This is the EEPROM. These are the 5 switching transistors. This is the 16-pin header down here that connects to the Keypad 40 keypad. And this is the 8-pin header that goes off to the Arduino. All right, I'm gonna get my camera up now. Right here. Okay. All right, and this is the full assembly here, and this is already connected to my Arduino. You can see the scanning LED on. I'm going to disconnect the Arduino just to show you how this connects together. Okay. Alright. This just simply plugs into that pin header here. Okay. That's it. So we just take that and it snaps into that pin header just like that. Alright. Okay. And then on this board, this is the 4017 IC. This is the PCF 8574, the EEPROM. The 5 switching transistors, and of course the 8-pin header that goes off to the Arduino. Alright, I want to bring a schematic up first before I connect anything, because I want to just show you how many pins it takes up on the Arduino. See if I can get this expanded up pretty good for you here. Alright, there's a ground, a +5. There's an interrupt pin that goes on to IO pin 12 on the Arduino. There's A5 and A4, which is for the I2C bus. There's a D2, that's for the clock for the 4017. There's a D3, that's for the reset for the 4017, and there's a D4, which is for the shift key. Okay, so there's 8 pins that go to the Arduino. It's not too bad. It doesn't tie up a lot of resources. All right, now I'll get back to my camera here. All right, I'm gonna plug the Arduino back in. Okay, and you can see the scanning LED came on, and now it's scanning. So the Arduino scanning the keypad. Okay, and I'm going to minimize this, and I'm going to bring up the serial monitor. Okay. Oh, I want to minimize that too. All right. Okay. All right, and we're going to connect. All right, and scanning. All right, there's a letter I, letter U, letter W, and we'll do a shift key. There's an uppercase H, uppercase P, do a couple of numbers. There's a number 3 and number 6. You get the idea. Okay, so this one works very well. The footprint isn't too bad. It's about maybe 3 1/8 inches on the encoder, and probably about 3 inches wide, and the whole assembly is about 5 1/4 inches long. Okay. The only thing with this is it ties up the processing resources with the Arduino, because it has to constantly scan this keypad. Okay. In part 2, the Key 2-wire is different. It's not going to have the scanning LED on it, because it isn't constantly scanning the keypad. What the 2-wire build does, when a key is pressed, it sends an interrupt to the Arduino, and then the Arduino will react to that interrupt. It'll go into a function on the code, and it'll go down and it'll read the keypad for which key was pressed, and it'll process that key for the character, and then it'll go back to its normal processing mode. It can be doing other things until another key is pressed, and then another interrupt is sent. So it doesn't tie up a lot of processing time with the Arduino. Okay, it's a little bit bigger footprint. I'll get into that on part 2. Okay, so I'll be back shortly, and we'll cover part 2. All right. Okay, I'm back with part 2 of the video. This one consists of the KeyEasy 2-wire manufactured board. As I stated earlier, this build's a little bit different than the KeyEasy 4017 encoder, which scans the keypad constantly, waiting for a key press. This board here does not scan the keypad. It waits for an interrupt, and then it will go and read which key was pressed. I'll just show a picture of this board right now. Okay, this is the board itself. Alright, there's 2 PCF8574 chips on here. The one is for the columns, and the other one is for the rows. Okay, and when a key is pressed, one of the ports on the row PCF8574 will go low and send an interrupt out to the Arduino. So then the Arduino knows the key was pressed. It will come down and it will read the PCF8574 for the row, and then it will read the PCF8574 for the columns. And then it'll go into the code and it'll process which key was pressed and which character is assigned to that key. This is the EEPROM here, and these here, they're 3 LM358P dual amplifiers. They're used for digital signal conditioning from the rows. Okay, because this is a little bit different setup. Like I said, it doesn't scan, and these PCF8574s, they react from a transition from a high to a low. What I found out anyhow. Maybe somebody else, can use them in a different manner, but it's about all I can find out. And that's how I had to design the circuitry around them. Okay, and this is the 16-pin header that connects to the keypad. And this is the 8-pin header that connects to the Arduino. Okay, I'm going to bring the schematic up here. All right, I'm going to shrink it down a little bit for right now. Okay. All right. This is the EEPROM. This is the PCF8574 for the columns. This over here is the PCF8574 for the rows, and these are the 3 dual op amps here that does the digital signal conditioning for the rows. Okay, what I like about this one is there's very minimal connections to the Arduino, so it doesn't take a lot of it doesn't consume a lot of I/O ports on the Arduino. Okay, I'm going to expand it here a little bit, and I'm going to get us down here. I want to show how many connections are involved with this. Okay. All right. There's a ground. There's a plus 5 volt. There's the interrupt that comes off of the interrupt here. Okay, it comes off this PCF8574. There's the A5 and the A4 for the I2C bus. And these 2 connections, pins, there's no connections. And this D4 is the shift key. So that's it. That's all the connections that go to the Arduino. Okay, as you can see, there's very limited resources that are used here. All right, so I'm gonna bring up the camera. Here, let me minimize this out of here. Okay, some of these videos, you can get quite involved when you're trying to explain this, because I want to try to keep it short, but yet, to the point. So you got to excuse some of my jittering around here. Okay, this is the board and the keypad connected to it. Okay, let me expand that up some. Alright, I already have the keypad connected. It's the same connection as the Key Easy 4017. It just plugs into the 16-pin header. I don't have to demonstrate that again, I don't believe. And these are all the ICs that are on it. Okay, this is the one PCF8574. This is the other one. These are the 3 dual op amps, and this is the EEPROM. And this is the pin header to the Arduino, and of course the keypad. Okay. All right, I'm gonna bring up the serial monitor again. Okay, because I have it connected to my Arduino already. I just want to do a demonstration on this for now. Okay. All right, I'll get rid of this. Let me bring this forward. Okay. All right, I'm going to connect to the Arduino. All right, we're connected. All right, and I'm gonna let's do a letter J. All right, you can see it says reading row 2, column 4, address 41, and it's a J. Okay, and we'll do a V. All right, same thing. There's the V. All right, let's do a U. All right, and we'll do, I don't know, let's do an X. All right, there's an X. Let's do a number. Let's do a 7. Let's do a 5. Okay, and let's do a shift and an H. Okay, and an H. Okay. All right, I had to hold this board down a little bit because these this isn't really mounted solid, and these pin headers here, like I said, they're not the highest quality, so I wanted to make sure that I get good connections for the demonstration here. All right, but all in all, it works very well. Okay, I didn't want to have any glitches. So like I said, what I like about this board is it doesn't tie a lot of resources up on the Arduino because it's not constantly scanning the keypad. It just waits for an interrupt. It doesn't even wait. It just as soon as an interrupt comes, it just goes to a function, reads the board, processes the key, and it's back onto its normal processing. So the only thing is it's a little bit bigger footprint. Okay, you're looking at about 4.5 inches by about maybe 4.25 inches, somewhere in that area. Okay, maybe I'm going to try to work it down a little bit, but I don't know. Maybe probably the best thing would be maybe do some surface mount soldering components on it. But for now, it works well, and I kind of prefer this one because it doesn't tie up a lot of resources wiring-wise or code-wise, processing-wise with the Arduino. All right, so if you want more information on these, there's a couple other builds on the onlykeypads.info site. All right, I'm working on some of the final prototyping on these boards, and once I get it all done, I'll probably make them available. You know, if somebody has interest in them. So I hope you enjoyed watching, and try to visit the site, the onlykeypads.info site. Okay, thanks for watching.